Welcome to the first chapter of this course. The materials needed are digital multimeter. Prepare a digital multimeter. Alligator clips. Alligator clips will be helpful when you measure resistors. You required 1.5 volt of battery as well as 9 volt of battery. I will measure the resistance of 220 ohm, 1 kilo ohm and 10 kilo ohm resistors. You can take any value of resistance according to your need to measure its value. First step, how to measure the voltage of the battery. First, connect the probes to the digital multimeter. COM terminal is for the negative and connect the red probe into the positive terminal. Now turn the selector to the DC voltage because we are measuring DC voltage of the battery. Before measuring the voltage, pay attention to the polarity. It's showing 1.24 volt. It means that you have connected proper terminals at the proper polarity. If you reversed it, you will get a wrong voltage value on the digital multimeter. Now let us check for 9 volt battery. Check out the polarity of each terminal, negative and positive. Check its value. It's showing exact value 9.65 volt. When the polarity is reversed, it shows the negative voltage. What happens if the battery is discharged? It shows lower than 9 volt. Means battery is discharged. And if you consider fully charged battery, it will show more than 9 volt. In this case, it is 9.64 volt. This is discharged battery and this one is fully charged battery. Now step 2 is how to measure the resistance of the resistor by using digital multimeter. To measure resistance, turn the selector knob to the resistance icon like this. Now let us take 220 ohms of resistor and measure its value. You can measure the value of resistor by using color coding method also. So red, brown and gold, these are the color codes of this particular resistor. Now connect terminals of the digital multimeter to the resistor and check its value. It's around 215 ohm. Now let's use alligator clips. It's showing again 215 ohms. Resistance is not affected by polarity because there is no positive and negative terminal to the resistor. So even after you reverse the probe polarity, the measured value is the same. Now let us check for the other resistors also by the same way. Let us try for 1 kilo ohm of resistor. Next, let us start. Again, you can do it by using color coding method. So these are the colors of these resistance in various bands. Now let us check it by using multimeter. It's showing around 977 ohms of resistor, which is slightly less than 1000 ohms. Same resistors you can measure by using color coding method also. That is another method which is not explained in this video. This video is dedicatedly for measurement of voltage and resistance value by using digital multimeter. You can measure the value of different resistance by using this meter. Now connect the multimeter probes to the resistance and it will show the exact value of that particular resistor. In this case it is 9730 ohms. I hope so you understand how to measure the values. Thanks for watching. Tools and materials required: digital multimeter, alligator clips, potentiometer of 100k ohms, speaker driver 8 ohm impedance, 220 ohm resistance, 1k and 10k ohm resistance. Step 1. Register color code. Typical resistors have a 4 band of colors. The 4th band indicates the deviation tolerance. Each color stands for number as shown in the table. We can read the resistance value with simple logic. The first and second color codes means the first and second. The third color code means multiplier. So the total resistance will be 22 into 10 equal to 220. You can verify this by using online resistance parameter calculator. You will get exact value of 220 ohms. This is the method in which we can measure the different resistance value by using digital multimeter. Let's try for 1 kilo ohm of resistance. It is showing approximately 0.977 kilo ohms. With the only third band changed to orange, the value reads 10k. Let us try for 10k. This is value of digital multimeter for that particular resistor. Now let us try to measure the value of potentiometer. This is of 100 kilo ohms. These are the terminals explanation. Let us use alligator clips. This is the easiest way to measure the value of any potentiometer. Now I connected the center terminal with the left end terminal. Let's see what happens when I rotate the shaft to the left end. The value of that potentiometer will change. Let us rotate in clockwise direction. You can see the change. Measuring a speaker, we use impedance instead of resistance as the essential speaker specification. At this point, you can understand that the impedance is AC circuit version resistance. It is mentioned on the back side of speaker. Now I will measure the DC resistance of the speaker instead of AC impedance. It reads about 8.2 ohms, almost the same value as the nominal impedance. Thanks for watching. Voltage and reference ground. Tools and materials required. Digital multimeter, breadboard, variable power supply. I set the voltage at 10 volt for the experiment of this chapter, like this. I required different values of resistances. Step 1. Preparing the circuit. These chapter's experiments are based on the textbook lab manual for DC AC fundamentals, a system approach by Thomas Floyd. This is voltage source Vs. The symbol is for fixed value resistor. The circuit has 3 resistors and there are 4 points for voltage measurements. I will build an actual circuit as shown on the right side. Check out carefully the position of the resistors and the measurement points. I am preparing 330, 680 and 1 kilo of resistors. I am preparing 330, then 660 and then 1 kilo ohm. Let us start with 330 ohm. Positive voltage line 680 ohm. The leads are on connected line. This is 1 kilo ohm of resistor. Negative voltage line. Check out the position of each measurement point A, B, C and D. Step 2. Preparing the power supply. I connected the red probe into the positive terminal and the black probe into the negative terminal. Notice that the measured voltage of the source is 10 volts. I use a pair of jumper cables for easier wiring. Step 3. Preparing the multimeter. I use alligator clips and jumper cables for easier measurement. Connect this like this. Step 4. Voltage across a resistor. Voltage is the difference in electric potential between 2 points. The measured value of the voltage between points A and D is 10 volts. Now let's measure between A and B. That is around 1.6 volt. Now let's measure in between points B and C. The voltage across the 680 ohm resistor, that is the voltage between points B and C, is around 3.4 volts. The voltage between point C and D is 4.9 volts. Key findings. Let's observe this very carefully. Whatever values of voltages at different points we have measured, that is indicated in this figure. These are the observations. The bigger value resistor has a bigger voltage value. Step 5. Reference ground. Ground is a reference point in an electrical circuit from which voltages are measured. At first, point D is set for the reference ground. Same process we have to adopt here to measure the voltage at different points. That is point number A, B, C and D. These are the different voltage values at different points. Key findings. 3. The voltage is similar to the height above the ground level. So the higher point has a higher voltage. Key findings 4 is the difference in between VAB, that is VA minus VB, then VBC, VB minus VC, and then VCD, that is VC minus VD. Step 6. Reference ground change to point C. Now I set point C as a new reference ground of the circuit. So voltage A is measured with respect to point C as 5.1 volts. The voltage at point B is 3.4 volts. The voltage at ground point C is 0.0 volts, which is reference voltage. And at point D, you will get minus 4.8 volts. Because point D is connected at the negative side. Key findings 5. As the reference ground changes, all voltage values change. Key findings 6. These are the different voltage references. Step 7. Reference ground change to point B. I set point B as a new reference ground of the circuit. Now when you change the reference point in that particular circuit, the voltage levels changes. Observe it very carefully. Again, D is connected at the negative side, that's why you will get negative voltage. The key findings 7. VB is grounded over here. Key findings 8. The voltage across each resistor is the same. Step 8. Reference ground change to point A. Same process we have to adopt here to measure the different voltage values. Every time we are changing the reference point, point B is negative. Hence we are getting voltage at point B is minus 1.6 volt. Again point C is negative, minus 5.1 volt. Point D is also negative, that is minus 10 volt. Here key findings 9. A point is at the reference. Voltages B, C and D are negative. Key findings 10. The voltage across each resistor is the same. Thanks for watching. Let's perform Ohm's law experiment. Tools and materials. Variable power supply, milliammeter, breadboard, 1 kilo ohm of resistor, 1.5 kilo ohm of resistance and 2.2 kilo ohm of resistor. One digital multimeter, Step 1. Key concept and theory. Ohm's law indicates I is equal to V by R, and it states that current is proportional to voltage and inversely proportional to resistance. Measuring resistors. The actual value of this 1 k ohm resistor is 0.98 k. For 1.5 k, actual value is 1.48 k. Similarly, measure for 2.2 kilo ohm of resistor, and its measured value is around 2.15 k. Circuit with 1 kilo ohm of resistor. Let's connect it on the breadboard. This is circuit diagram with resistor and voltage supply Vs. Observe this very carefully. Resistor we have to connect by this way on breadboard. Now let us connect voltage supply Vs. With an ammeter I can check the current level as voltage changes. It's a negative type ammeter. Be careful to check out the connection type of ammeter you use. The circuit is almost the same as the calculation from Ohm's law. You can find out the value of I by measuring V and R. If voltage value is 4 volt and there are different values of resistances, you can easily find out the value of I. Current proportionally increases as voltage rises. Now voltage is 10. Step 4 is circuit with 1.5 k ohm resistor. Secondly, I will use a 1.5 k ohm resistor. And the actual value of this resistor is 1.48 k ohm. The result is similar to the calculated value from Ohm's law. You can see the observations. As you can see, the current proportionally increases as voltage rises. Now change the value of voltage at 8 volt. We are just following that observation table. For different value of resistor, that is 1.48 k, I is 5.40 milliampere. This process is repetitive. We are measuring the current for different value of voltages and for different values of resistances as shown in the figure, which is indicated at the right side. Step 5, circuit with 2.2k ohm. Same process we have to adopt here just like previous two resistances. Read the captions properly. We are measuring current for 2.15k of resistance for different voltage values. Increase the voltage at 6 volt. As you can see, the current proportionally increases as voltage rises. For 8 volt, and the current value at the same voltage is similar that the circuit with 1.5k ohm resistor. That is smaller value. Summary of this result is the result shows that the current increases as voltage rises for the same resistance. And the current is smaller when the circuit has higher resistance, because it is registering more current. We can plot the graph as shown on the right side, and we can conclude here for Ohm's law. Thanks for watching. Series circuit and Kirchhoff's voltage law. Tools and materials. Variable power supply, ammeter, breadboard, some resistors of different values, Step 1, Key concept and theory. Series circuit. In a series circuit, the current is the same for all elements. Total resistance RT equals the sum of individual resistances in a series circuit. Total voltage VT is the sum of the voltage drops of the individual resistors. Now KVL. KVL states that the directed sum of the voltages around any closed loop is 0. Step 2, circuit assembly. I will put 4 resistors on a breadboard, and I will use one piece of U-shaped jumper wire to complete the connection. Let us take resistors one by one and connect it on the breadboard. Observe this very carefully. You can repeat this process if you have these components and breadboard at your home. Step 3. Measuring resistors. You can get the nominal value of RT as 5.03 k ohms by adding all the resistors values. Here we have listed some ideal resistors values and we are going to measure it by digital multimeter. So first resistor R1 is 1K and we are getting 0.98K value. For R2 1.5K you are getting 1.48K value. And for other resistors you can check it. We are getting some difference in between listed value and measured value of the resistor. You can check for RT also. Key findings. Notice that the measured RT equals the sum of all four resistance values. Step 4. Measuring current with a digital multimeter. See how to measure the current. You can measure the current with a multimeter. First set the knob on the milliampere indicator. Connect the positive probe with the positive terminal of the power supply. And connect the negative probe to the R1 resistor. According to Ohm's law, you can measure the value of I with the help of V and R. About 3.01 milliampere current is there. Step 5. Measuring current with an ammeter. Next I will measure current with an ammeter. Be careful to check out the connection type of ammeter you use. Make connection according to this. When you provide 15 volt of voltage, you will get 3.01 milliampere current on the milliammeter also. Step 6. Measuring voltage across the circuit and resistor. Now I will measure actual voltage across resistors. I am using alligator clips and jumper wires for easier measurement. The voltage drop across R1 VAB is 2.96 volts. So according to that, we have to measure this value for each combination. Just follow the observation table and complete this process. VCD is 6.52 volt. VD is 0.99 volt. And VEA is minus 14.95 volt. Key findings are: the result verifies that the total voltage RT is the sum of the voltage drops of all resistors. New key findings is Kirchhoff's voltage law. The result shows that the sum of the voltage around the series circuit is 0. Thanks for watching. Voltage dividers. Let's start. Tools and materials. Step 1. Key concept and theory. In a series circuit, the current IT is the same for all resistors, and IT can be expressed as VT by RT by Ohm's law, that is V is equal to IR. V out is a fraction of V in. We can calculate output voltage at each point with this formula. Step 2. Circuit assembly. In this experiment, I will put 4 resistors on a breadboard. Check out the position and value of the resistors. 330 ohm. Observe properly. 470 ohm. U-shaped jumper. (680 ohm) resistor. You have to connect all the resistances as given on the breadboard on the right hand side. And last one for 1 kilo ohm of resistor. Step 3. Measuring resistances. As we have measured resistance value in previous chapters, By the same way, same process, we have to do it again. Just go on repeating the process as shown in the observation table. Step 4, voltage drop calculation. I am connecting the source voltage to the circuit. Let's make it around 10 volt. Use alligator clips and jumper wires for easier measurement. V1 can be calculated as Vt multiplied by Rt upon It. V1 is 1.33 volt. Around it is 1.36. V2 can be calculated as Vt multiplied by R2 by Rt. By the same way, we have to measure these values for the different resistances values. V4 is 4 volt. Multimeter showing 3.95 volt. Step 5, voltage divider calculation. How much voltage is divided in between two branches, that we are going to find out by using this experimentation. Step 6, designing voltage divider. How to make 5 volt voltage divider circuit. You should get approximately 4.97, that is around equal to 5 volt at the output, that is V out. Connect all these resistors in series. Our calculated V out is 4.97 volt. We can make a 7.5 volt output voltage by rearranging the circuit. We can make a 7.5 output voltage by setting the resistance of 0.75. I am connecting 330 ohm and 1 kilo ohm resistors in series. The calculated V out is 7.52 volt. Step 7, voltage divider with a potentiometer. In this experiment, I will use a 1 kilo ohm potentiometer. Potential measurement we have already done in the previous chapter. I am measuring the resistance between the outer terminals. It reads around 1.036 kilo ohms, almost same as 1K. Now I connect the center and the left terminal. When I turn the shaft to the right end, it reads as 1.034 ohms, and turning the shaft to the left end, it reads as about 6 ohms, slightly more than 0. We can make a variable output voltage with a potentiometer. A potentiometer is a variable combination of two resistors. When pot 2 is 1 kilo ohms, the voltage output can be maximized. We can calculate the maximum output voltage as 8.17 volts. Calculation is given over here. What is the minimum output voltage? The voltage output can be minimized when pot 2 is 0 ohms. Now I am building the circuit. Observe it very carefully. Connect the resistances, potentiometer, jumpers, and complete the circuit. Give the power voltage. Let's measure the actual output voltage. The calculated maximum Vout is around 8.17 volt and the measured value is 7.91 volt. Minimum Vout is 2.61 volt. It is 2.48 volt. Now turning the shaft, I can make any output voltage value between 2.48 and 7.91 volts. Thanks for watching. Let's start Arduino. Topic is Arduino and breadboard. This is Arduino Mega. This is Arduino Uno. Arduino Lilypad. Arduino Nano. Arduino Pro Micro. These are the various models of Arduino. This one is Arduino Pro Mini. 400-point breadboard. Inside the breadboard, one metal plate connects 25 points. This is inside the breadboard. One metal plate connects 5 points here. Arduino as a power supply. Parts list: LED, 220 ohm resistor. These are the different ports and its pins. Here 5 volt pin we have to connect. This is ground pin. Labels are there on Arduino, you can see. Now connect it on breadboard. 5V to positive line. And ground to negative line. Connect LED, long bent pin upside to 5V. Long pin is anode, short one is cathode. Connect one resistor for protection of the LED, which is of 220 ohm resistor. It is used to resist the flow of current. Connect it properly. It should be aligned properly. To 5V line. After giving the supply, you can see LED is turned on. Arduino as a power supply with switch. This type of connections we have to perform now. Let's connect these components one by one. This is a switch that is called as on-off switch. Connect it on the breadboard like this. We have already connected LED, one connecting wire, and the supply cables in between breadboard and Arduino. Connect 220 ohm of resistor. In previous video, when we provide the supply, LED was directly on off, but here we are connecting switch so that according to our need we can turn on and off your LED. Connect one wire. We are connecting in between LED and switch. Now let's check by giving supply. You can turn on and off the LED by using switch. Thank you. Digital output LED blink. Let's make LED on and off. This type of connections we have to do it now. Detach wire from 5V pin. Connect to pin number 11. Now make the connections as shown in this video. This is long bent pin. Arduino coding. Let's check the source code. Follow this process. You have to install this Arduino software in your laptop or PC, and you have to try this code as shown here. Pin plus mode setting a role for the pin. 11 number of working pin. The type of pins work only two options, either input or output. Semicolon, every sentence must end with the semicolon. And here write digital write 11 pin as a high and semicolon. Digital working only on off, that is 5 volt or 0 volt. This is working pin. High for 5 volt and low for 0 volt. Code for LED blink. Copy and paste this code again and make it low. We have to provide the delay in between high and low, that is LED on and off, for 1000 millisecond, and same delay for the LED off. Let's try and you can check the output. Now let's write the code for faster blink. Reduce the delay so that on and off, that is high and low of the LED, will be faster. Let's try. Thank you for watching. Digital input with switch and LED. Let's provide digital input. We have to design such type of circuit. This code we have to use now. Just follow the instructions properly. Let's connect the switch on the breadboard. We have already discussed how to connect the switch on the breadboard in previous lectures. This is 10k ohm resistor. Connect it on the breadboard. Connect the wire. Pin number 2 is important over here. Make sure that all components are inserted properly. Give the input supply. Code for digital input. Pin number 2 will be input. Delay we have used over here. Modify your program like this. Working pin is pin number 2. Observe the changes very carefully. What happens? Let's change the code for serial communication. This baud rate is around 9600, and for the print just use 0 as off and 1 as on. Let's check now. This is the code for LED with digital input. Pin number 2 is in the read mode, and in the write mode there is a pin number 11. Here we are giving digital input to turn on the LED. You can see it's working properly. Thanks for watching. Multiple LED blink. Let's start. How to blink the multiple LEDs by using Arduino. Pin number 9, 10 and 11. These are important pins over here. Arduino we are using. Let's connect the multiple LEDs and registers on the breadboard. Check the connections properly. Longer pin upward. Shorten pin downside. If possible, choose multicolor LEDs. For the better effect. Here we are use red, green and blue color LED. Insert it properly. Let's connect the resistors over here to resist the flow of current, so that your LEDs will not damage from the high voltage. Connect to the ground line. Here also same, and for next LED 2. This is ground pin. Connect it to the ground of the breadboard, that is negative pin. Positive, that is anode terminal of each LED we have to connect to the pins which we have already mentioned earlier, that is pin number 11, 10 and 9. One for each LED. So here we are connecting anode of the LED to the port of the Arduino to the pin number 9, 10 and 11. We have choose that particular color of wire for particular color of LED so that confusion will not be occurred. Still voltage supply is not given. The code for this is just observe the code properly and make necessary changes according to our need. Earlier we have turned on and off only one LED, so our program was for only one LED. So here we have to modify it for 3 LEDs. After giving the supply, you can see all pins are blinking. Change code for blink one by one. Make these necessary corrections. So according to our source code, your program will run and you can see the changes on the circuit. You can see one by one LED is blinking. Thanks for watching. Color LED with switches. Here we are going to use multicolor LED and multiple switches. So this type of connection we have to make by using pin number 2, 3 and 4 of Arduino. So 3 switches will be there. Let's start. Just observe the connections very carefully. On every pin of the port something is labeled, so that pin is very important part of that particular Arduino. So observe the connections. Five volt to red plus line. Three switches are there. Connect it on the breadboard as shown here. It should be properly inserted. This type of mini projects are very important and understand while work on the Arduino. Once you get the basic idea, you can implement for the major project. So here we are going to use 10k of resistors, 3 different resistors over here for each LED and switches. Connect it as per the requirement. You have to connect the remaining resistance all the same way. Connect the extra wires whenever necessary. Now connect these connecting wires. In between switch and the so we choose pin number 4 over here for first switch. For second switch we are connected other terminal of this connecting wire to the pin number 3, and the same process you have to adopt for the third switch also, and connect it on the pin number 2. Now let's see the code. Question is where we are writing this code. You have to install this Arduino software in your laptop or PC, and you can write down such type of code there. So according to our need, according to our requirement, you can modify this code. If you want to write same type of instructions again and again, so they just copy and paste over there and modify it according to your need. Code plays a very important role in such type of projects, so your code should be properly optimized. Pin number 2, 3 and 4 you have used to read the digital data, so use it properly. First LED is on by using switch, second one is also working, and third one is also working. You can on and off the LEDs by using switches like this. Now change to RGB LEDs. This is called as single multicolor LED, which consists of 4 terminals. You can see its terminals. Let's connect it on the breadboard. We have removed the previous LEDs and resistors. All 3 colors are present in a single LED. Now connect it properly by using 220 ohm of resistor. It is vertically connected. You can check for the green one. What is the main motto of connecting the resistors? That is to control the flow of current, so that whatever required voltage you have to provide to the terminal of the LED, that should go there. If extra voltage comes, that will be breakdown. So there will be protection to this LED by using resistors. Now let's test it. We have not connected the wire in between LED and the ground side, so let's do it. Insert it properly into that hole so that connections and circuit will be complete. So in a single LED, three colors are there. Connect that LED with the Arduino. Now let's start it. For the code, this is your same code. Give the input supply and let's check it. So by turning on and off the switch, you can control the LED. You can see here LEDs also turn on and off in three different colors. So by this way you can connect multiple LEDs also and single multicolor LED also. Thanks for watching this video. Color LED with switches. Here we are going to use multicolor LED and multiple switches. So this type of connection we have to make by using pin number 2, 3 and 4 of Uno Arduino. So 3 switches will be there. Let's start. Just observe the connections very carefully. On every pin of the port something is labeled, so that pin is very important part of that particular Arduino. So observe the connections. Five volt to red plus line, 3 switches are there. Connect it on the breadboard as shown here. It should be properly inserted. This type of mini projects are very important and understand while work on the Arduino. Once you get the basic idea, you can implement for the major project. So here we are going to use 10k of resistance, 3 different resistance over here for each LED and switches. Connect it as per the requirement. You have to connect the remaining resistance all the same way. Connect the extra wires whenever necessary. Now connect these connecting wires. In between switch and the so we choose pin number 4 over here for first switch. For second switch we are connected other terminal of this connecting wire to the pin number 3, and the same process you have to adopt for the third switch also, and connect it on the pin number 2. Now let's see the code. Question is where we are writing this code. You have to install this Arduino software in your laptop or PC, and you can write down such type of code there. So according to our need, according to our requirement, you can modify this code. If you want to write same type of instructions again and again, so they just copy and paste over there and modify it according to your need. Code plays a very important role in such type of projects, so your code should be properly optimized. Pin number 2, 3 and 4 you have used to read the digital data, so use it properly. First LED is on by using switch, second one is also working, and third one is also working. You can on and off the LEDs by using switches like this. Now change to RGB LEDs. This is called as single multicolor LED, which consists of 4 terminals. You can see its terminals. Let's connect it on the breadboard. We have removed the previous LEDs and registers. All 3 colors are present in a single LED. Now connect it properly by using 220 ohm of resistor. It is vertically connected. You can check for the green one. What is the main motto of connecting the resistors? That is to control the flow of current, so that whatever required voltage you have to provide to the terminal of the LED, that should go there. If extra voltage comes, that will be breakdown. So there will be protection to this LED by using resistors. Now let's test it. We have not connected the wire in between LED and the ground side, so let's do it. Insert it properly into that hole so that connections and circuit will be complete. So in a single LED, 3 colors are there. Connect that LED with the Arduino. Now let's start it for the code. This is your same code. Give the input supply and let's check it. So by turning on and off the switch, you can control the LED. You can see here LEDs also turn on and off in 3 different colors. So by this way you can connect multiple LEDs also and single multicolor LED also. Thanks for watching this video. Analog output and input to the Arduino. Let's check what we have required to complete this mini project. Earlier we have connected LEDs, that is single LED, multiple LED and multicolor LED with the Arduino. Make the connection properly, push hard to left side so that it should be properly inserted in that particular breadboard. You can see remaining half of the circuit is already connected, just like previous chapter. Now we have to do the remaining connections over here. Connect the connecting wires. We have connected here 5 volt and ground properly. In any electronic circuit, it is very important to make the connections. Now see, it is connected to A0 pin of the port A. Now code for today is A0 input controls the brightness of the pin number 11 LED. Now let's make the program and we have to change that particular code for the brightness. Voltage changes between 0 to 5 volt. So we have to write the electrical output, that you can say analog output, and the range in will be between 0 to 255, that is 256 for the brightness. Maximum brightness comes at the 255 and lowest at the 0. So don't keep it as 0, make it some value so that the brightness can be observed by the eyes. So it is 20% brightness by 50 upon 256. So brightness controls it by using the instructions. Sensing input voltage level for this value. It is not necessary to write the same code as I am doing over here. You can write down it according to your own way. This preset type of component is used to reduce and increase the brightness of the LED. Summary of this Arduino job. There is digital and input. You can give the input as a digital, output as a digital also you can take, same for the analog. That also we have completed in the previous chapters. Now let's connect the another port for the same way. We have to make the connections just like first port for the port number 2 and port number 3. If you want to understand these concepts, you have to play with the electronics components. You have to test it on the different environments, different situations. After learning this, try it yourself so that you will become expert in this Arduino and electronic component circuit design. Just check the code for RGB color mix. Copy and paste this code because we want it again and again, and just change the pin number. Modify it according to your need. We have just put one cover over the multicolor LED so that you can observe the brightness very properly. It looks great. Thanks for watching this video. Analog output and input to the Arduino. Let's check what we have required to complete this mini project. Earlier we have connected LEDs, that is single LED, multiple LED and multicolor LED with the Arduino. Make the connection properly. Push hard to left side so that it should be properly inserted in that particular breadboard. You can see remaining half of the circuit is already connected, just like previous chapter. Now we have to do the remaining connections over here. connect the connecting wires. We have connected here 5 volt and ground properly. In any electronic circuit, it is very important to make the connections. Now see, it is connected to A0 pin of the port A. Now code for today is A0 input controls the brightness of the pin number 11 LED. Now let's make the program, and we have to change that particular code for the brightness. Voltage changes between 0 to 5 volt. So we have to write the electrical output, that you can say analog output, and the range in will be between 0 to 255, that is 256 for the brightness. Maximum brightness comes at the 255 and lowest at the 0. So don't keep it as 0, make it some value so that the brightness can be observed by the eyes. So it is 20% brightness by 50 upon 256. So brightness controls it by using the instructions. Sensing input voltage level for this value. It is not necessary to write the same code as I am doing over here. You can write down it according to your own way. This preset type of component is used to reduce and increase the brightness of the LED. Summary of this Arduino job. There is digital and input. You can give the input as a digital, output as a digital also you can take, same for the analog. That also we have completed in the previous chapters. Now let's connect the another port for the same way. We have to make the connections just like first port for the port number 2 and port number 3. If you want to understand these concepts, you have to play with the electronics components. You have to test it on the different environments, different situations. After learning this, try it yourself so that you will become expert in this Arduino and electronic component circuit design. Just check the code for RGB color mix. Copy and paste this code because we want it again and again, and just change the pin number. Modify it according to your need. We have just put one cover over the multicolor LED so that you can observe the brightness very properly. It looks great. Thanks for watching this video. Transforming vintage Wi-Fi into a Bluetooth audio system. This is Bluetooth 4.0 receiver board. Assembling the Bluetooth board case. You can see this is DC adapter input jack. So connect this case properly so that circuit will be safe inside this case. Inserting M3 nut. So here we have to insert one and there here second one. Here we are transforming vintage Wi-Fi into a Bluetooth audio system. So your Bluetooth model is safe within this case now. Right channel and this one is left channel and this is DC adapter. This is your audio player, so you can see the working status. You have connected this audio player with this speaker sound recorder. Thanks for watching this video. How to make a drone at home. Let's start it. Let's take sheet and scale. First of all, fix up the dimension of this particular drone. Once you have decided the dimension, we have to cut this sheet according to that by using scale. The sheet should be as small as possible without much high load. We have to make the shape of that particular drone in such a way that it should look like a drone. Now various assemblies we have to use over here with the DC motors. Connect it properly by soldering. Now let's connect the battery with this board. Now we have to connect that assembly by using this dual tape on that particular body of the drone and paste battery on this side so that glue will stick over there. Glue this properly so that it should be stick in any environment. If it falls, it should not be detached from that body. Now connect these fans. We required here 4 fans. So connect it as on their proper position. This one is third one. And last fourth one. This is joystick, which is synchronized with the transmitter of this module. Now let's start. You can control this drone by joystick and you can fly it anywhere. You can see it's working. By this way, you can design your own drone at your home. Thanks for watching this video. Top 3 VC547 based projects. Let's start it. Use transistor BC547, LEDs, capacitors to make this first project. The explanation about this project is given in the description. Though it's very small project, but they are very important for our day-to-day life. The good electronics engineer is that one who designed the project at the less space and with the less amount. This is multifunction RGB LED. We have already seen it while studying Arduino chapters. You can design these projects on breadboard or PCB also. Unwanted leads or terminals of these components you have to detach from its body. Solder it properly. This is 470 ohm of resistor and this is 12K resistor. If you don't want that much terminal size, you can cut it like this. You can see this assembly. Connect 12 volt power supply. Here negative 12 volt. Just like VCC and minus VE. You can see the LEDs are glowing. It's just wow. We have performed this type of experiments on Arduino. You can design your own disco lights for Diwali at your home. Next, move for the another one. This is BC547 transistor. Collector, base and emitter, these are the terminals of this transistor BC547. Let's connect one transistor with another. Again use third transistor and connect it with the second one. These are the terminals of this transistor. This is buzzer. Connect it with the first transistor as shown here. Negative we have connected. Just observe it properly where we are connected the positive terminal of the buzzer. We have connected the positive to the collector of the second transistor and collector of the third transistor. This is LED. Let's connect it across your buzzer. You can see the level of soldering. Remove unwanted leads. Make antenna coil with copper wire. This is copper wire. We have to connect this with the circuit. Just check the connections. Connect antenna coil with base pin of the third transistor. This is positive power wire. Connect to the third transistor. Negative power wire connected to the first transistor. This is lithium battery of 4.7 volt. Connect positive to the positive and negative to the negative of the battery. You can see LED is glowing. When you bring your hand to the antenna or some electronic charges across the antenna, your LED will be turned on and off. So this type of mini project you can design by using BC547 transistor. Thanks for watching. Again, I am going to design third mini project in the continuation with this video. Iron Man arc reactor. This is copper wire of 18 gauge. We have to connect many LEDs over here. I hope everybody have seen Iron Man movie. So in that movie there is one arc reactor very near to the heart of the Iron Man. So this type of arc reactor we are going to design by using LEDs and BC547 transistor. Observe it very carefully. Unwanted leads of the LEDs we have to remove. As I said earlier, we have to use lots of LEDs to make this arc reactor. You should have interest to develop such type of mini projects by using different electronic components. So starting from the first chapter in this course, we have introduced how to test the electronic components, how to measure the resistance value, potentiometer value, how to measure the current, voltages across the different points. After that, we have gone through the Arduino. So lots of mini projects, around 7 to 8 mini projects we have designed in this course by using Arduino. One another thing, you can glow these LEDs of arc reactor by using Arduino Uno also, as we have already learned in the previous chapters of Arduino. As I already told you, here we are going to use lots of LEDs. Depending upon the diameter of this circle, you require that much of LEDs. If diameter is less, number of LEDs requirement will be less. Let's go further. Remove unwanted leads. LED connections are almost over throughout the arc reactor. Now let's connect the controller pin and collector pin of the transistors to the group of the LEDs connected. So multiple transistors we are using for the group of the LEDs. Some capacitors also we are going to connect here for the storing of the charges. Look at the connections of the capacitor, how it is connected. So again, capacitor have two terminals, anode and cathode, that is positive and negative respectively. Connect some resistors to resist the flow of current. Connect all these resistors over here at the common point. And we have to give the supply now. Red one means positive, black one means negative. We have connected to the battery. You can see over here LEDs in the group are blinking. So it works as again new type of disco light. So this type of mini projects you can design by using transistors, LEDs, resistor, capacitors. Thank you for watching this video.